So with this first example, we haven't met this before, but I'm hoping you can use what you know about the ones we've already done. So we've got x, y is inversely proportional to the cube of x. So that's what our next column would look like, with y coming at the end. And y is proportional to 1 over x cubed. That's our proportionality statement. So in a minute we're going to write that as a formula. So we're told that x is 3 and y is 2. So 1 over 3 cubed, sorry, is 1 over 27. So 2 divided by 1 over 27 is 54. So you've got 54 over x cubed. Now some of you may, at this point, prefer to use the formula from here on, because all I'm going to do now is make x equal 5, so I'm going to do y equals 54 over 5 cubed, and then you might feel confident enough to rearrange the formula and do part C. If you're happy doing that, brilliant, absolutely brilliant. I'm going to persevere with my table for part B and C. So x is 5, so 1 over 5 cubed would be 1 over 125, and 54 times that would be 54 over 125, and I'm very happy leaving my answer like that, unless it says, rounding it to one decimal place. I mean, I will work it out as well. So that's 0.432. No context here, no units to remember, so we're all okay. So the only difference between this and the previous one is that it's x cubed, so I had to do 5 cubed. Could have done that here. If you'd made x equal to 5, you would have got exactly the same answer straight away, wouldn't you? For part C, again, you can rearrange the formula if you wish. It's the switcheroo, but I'm going to persevere with my method. So I've got 6.75. I'm going to divide that by 54. And that's really easy now, isn't it? So just let me remind you how we go from here to here. We cube that number, and then we do 1 over it. We flip it. So to go backwards, I'm going to flip it, which is just 8, and then I'm going to find the cube root of it. And the cube root of 8 is 2. It's 2. Oh, so that was the first new sort that we've met today. Y is inversely proportional to the cube of x. I'll just pause at that point and give you a couple of minutes to have a go at the last one, if you haven't finished it off. With the last one, y is inversely proportional to the square root of x. So inversely, so it's 1 over, square root, so it looks like that. Our proportionality statement would look like this. And in a minute we're going to write a formula with the multiplier. So when x is 9, y is 2. 1 over the square root of that is a third. After divided by before, 2 divided by 1/3 is 6. So I've set my problem up, and I said at that point there's nothing wrong with you just using the formula if you're confident with that. I'm going to persevere with my table approach. So part B, we're told to calculate y when x is 4. 1 over the square root of 4 multiplied by 6, y is 3. And C, y is 6. Divide that by 6, I get 1. And I think Finn was very sensible yesterday when he said, right, well in this case let's write that as 1 over 1. So what I did here was I square rooted and then flipped it. So I need to do the reverse. I need to flip it and then the reverse of square rooting is squaring it. If I flip it, I get 1, and square it, I get 1. So the answer there is 1. And that finishes really all of the different sorts of proportion that we're likely to meet. They could throw a curveball in there. You could have a cube root maybe rather than a square root, but I'm hoping that you're now in a position to sort of to spot that. We talked about the graph of y is proportional to 1 over x yesterday, looking like this. Actually, there's a mirror bit here, but I'm not going to worry about that. In fact, any reciprocal graph, whether it's x squared, x cubed, or the square root of x, will have a similar sort of shape. Inverse proportion, it's not like direct proportion where the curves differ. It always looks roughly the same as that. And we're going to look at a graph question in just a minute.